Welcome to today's lecture. Okay, so today we're going to do about graph transformations and inverse functions. Okay, so this is going to be our focus. Okay, it is an interesting part. Okay, so please make sure you watch what is happening here. Okay, so the first thing is we are going to talk about our learning objectives. Okay, so I'm going to make sure by the end of this video you're going to be able to apply transformations. Okay, so this is the first thing. You're going to apply shifts, stretch, and reflection. Okay, so given all trigonometric graphs, and we are going to apply these shifts, stretch, and reflection. Okay, then the other thing is we are going to identify and sketch inverse trigonometry. Okay, I believe you have seen this function arcsin. Okay, arcsin, which this one. Okay, so we are going to identify them and sketch them: arcsin, arccos, and arctan. Okay, then the third one is going to understand the domain and range and restrictions of the inverse and trig functions. Okay, so after drawing this, you're going to understand their domain, their range, and their restrictions. Okay, so this is this for today. Okay, so make sure you subscribe so that you don't miss other lessons which are interesting. For now, I believe we are now able to draw the simple trig graphs, which are sine graph, cosine, and tan graph. Okay, so let's go. Let's hope you are now able to. If you are not, watch this video and make sure you can be able to draw these graphs. Okay, now we are talking about the transformations of these graphs. Okay, so we want to see the transformation. Okay, so the general form of the transformation is y is equals to a f. Okay, this f means the sine, cos, or tan. Okay, so any one of them. Then we have bx plus c plus d here. Okay, so this is what we are going to see. Okay, so I'm going to explain the meaning of each one of these. Okay, so this meaning of a, this one. Okay, this meaning of a, it means that the graph was stretched to the y-axis. Okay, so when you have your graph or you draw a basic graph, if the a is being added here, it means that you are going to multiply each y value by a. Okay, multiply each y value by a. Okay, so this is the meaning of a. And if a is negative, okay, if this a is negative, this means that the graph has been reflected by the x-axis. Okay, so it's reflection by x-axis. Okay, so this means that the graph is reflected by x-axis. Okay, so what you're going to do is when you see this a, you're going to check if it's negative. If it's negative, it has been reflected by x-axis. And what you're going to do is you're going to multiply each y value by a, then reflect. Okay, so this is the meaning of this. This is the meaning of this a. Okay, let's go on b. Okay, so this b, it means that this graph was stretched on x-axis. Okay, so it has been stretched on x-axis. Okay, so this means that you are going to divide each value by b. Okay, so you are going to divide each value by b. Okay, so when this b is negative, if b is negative, okay, this means that this graph has been reflected by the y-axis. Okay, okay, so make sure you take these notes down and make sure you remember this. Okay, so this is the meaning of a and b. Okay, this means that if a is negative, uh, the graph is reflected by the x-axis, and if b is negative, the graph is reflected by y-axis. Okay, so we are going to do an example. We are going to see how this affects. Okay, so now let's go on c. If this c, okay, this means that the graph has been translated to the along x-axis. Okay, the graph has been translated along x-axis. Okay, so this means that you are going to move the graph horizontal. Okay, so if this c is negative, if c is negative, this means that you are going to go to the right. Okay, so you are going to move c units to the right. Okay, and if c is positive, okay, this means that you are going to move c units to the left. Okay, so this is what you do. And then if let's go on d. Okay, so D, this means that it's going to be translation along the y-axis. Okay, so it means that it is a translated along y-axis. Okay, so in this case, if C is negative, this means that this graph has been moved downwards. Okay, and if this C is positive, if this D, yeah, is D. Okay, if this D is negative, this means that it has been moved downwards. And if this d is positive here, this means that the graph has been moved upwards. Okay, so these are the transformations we are going to do. Okay, so I'm going to show you how do we draw these graphs. Okay, so make sure you remember each of these. If the graph is in this form, okay, if for example it is in this form, y is equals to a sine x plus pi over 2 plus a certain number d. Okay, so this is the meaning of the graph. Okay, so I'm going to show you how do we draw this graph step by step from the first graph. Okay, so the first thing is you make sure you are able to draw this graph, the graph of sine x. Okay, and from here we are going to transform it to here. Now, let's talk about inverse trigonometric functions. Okay, so we're going to talk about them. Okay, so the first thing you are going to do is to restrict the domain. This is the common thing. Okay, so let's see why do we do that. Okay, so trigonometric functions are not one-to-one functions. Okay, so if you see that, if you don't know what is a one-to-one function, is when we draw a function. Let me use a graph of sine as an example. Okay, I'm just going to draw. Okay, so in this if it's a one-to-one function, this means that the horizontal line, any horizontal line, okay, should cut the graph once. Okay, so this means that trigonometric functions are not one-to-one because it cuts the graph many times. Okay, so they are not one-to-one. Okay, so we have to restrict their domain. Okay, so we are going to cut a certain point. Let's say in this case we choose to cut from here to here. Then you draw this graph. Okay, so this is the restricting the domain. Okay, so that is the only way we can find their inverses. Okay, so this means that you can have a trick that the only one-to-one functions have inverses, but in these cases we're going to restrict their domains, like taking a part where it doesn't cut twice. Okay, so you can take this part from here to here, then draw, or from here to here, then draw. Okay, so this is it. Okay, so we're going to restrict these domains so that we can have the inverse function. Okay, so stay here and see how we're going to draw this graph. Let's start with the sine graph. Okay, so this is the arcsin. Okay, so we're going to first draw the graph of sine. Okay, so just going to draw it a little bit fast. I hope you know. You should know now. You should know by now to draw this graph. Okay, so the graph of sine. I'm just going to draw this short part. Okay, so here you can see that here is pi over 2 and here is pi over 2. Okay, you can use degrees if you want, but you should know how to convert them. Okay, you can watch my video where I teach how to convert this graphs. Okay, so here you can see that here is pi and here is pi. Okay, so I'm going to use this, and this is going to be 1 and this is going to be 1. Okay, so I'm going to use this graph. Okay, so when we say that we are finding a sine, an inverse of a graph, okay, so the only thing we are doing here, we are changing y values to become x values. Okay, so here we have x and here we have y. Okay, so when we say that we are finding an inverse of a graph, we are reflecting it by the line y is equals to x, or we are changing y values to become x values and x values to become y values. Okay, so this was that. Okay, so as easy as that, we're just going to change this to put it here and this to put it here so that we change these values. Okay, so how do we do that? The first thing is to restrict domains. Okay, so to restrict domains, we have to cut here and cut here. Okay, so this means that we are making our graph a one-to-one. Okay, so research about one-to-one functions and know what they mean. So we are restricting the graph. We're going to cut here and cut here. Okay, so we're going to draw only this middle part. We're going to draw only this middle part. What we're going to do is we're going to use this line y is equals to x to reflect our graph. Okay, so the line y is equals to x, it passes through the origin like this. Okay, so reflecting the graph is just making sure you take a mirror here and put this image this side and put this image this side. Okay, so you are putting this image this side and putting this image this side. Okay, so you are going to use this line. Okay, so this is it. Okay, so this means that our graph is going to look like this. Okay, make sure you understood how to do this. Okay, so this means that our graph is going to do this. Okay. Okay, now we are changing x values to become y and y values to become x. Okay, so this means that this one, this part this part was this side of this line. Okay, so it's going to come to this side of this line. Okay, so this is that is going to do like this. Okay, this is this part. Okay, this part from here to here. Okay, it changed to become this one. Okay, and this part again is going to change to become this side. Okay, from this line we are taking a mirror from this line. Okay, so it's going to become this part. Okay, so this means it's going to be like this. Okay, so that's it. Now we just have to make sure that this value, this x value, is going to become on y, and this y value, this one was supposed to minus 2 pi over 2. So this y is going to come to the y. Okay, so here this means that our limit here is going to be pi over 2, and here is going to become minus pi over 2. Okay, so that's it. And here is going to become this y value was 1, so this means that it's going to become 1 here, and this one was minus 1. Okay, so this means that it's going to become minus 1. Okay, so this was reflection. We just have to reflect the graph by the line y is equals to x. Okay, so that's the finding of an inverse. Okay, so as easy as that, we have successfully drawn this graph. This becomes our graph of y is equals to sine inverse of x. Okay, now let's go to the graph of arccos. Okay, so arccos means the inverse of cos. Okay, so the first thing, like we did last time, we just have to draw the graph of cos. Okay, so let's draw the graph of cos. This was the graph of cos. It starts from here and it goes this way. Okay, so I'm just going to draw a short one because I'm going to cut it anyway. Okay, so here it becomes pi over 2, and here it becomes pi, and here it's going to become 3 pi over 2. So here is going to be minus pi over 2, and here is going to become minus pi, and so on and so on. Okay, so this is it. Okay, so make sure you are able to draw this graph. You can research about how to draw. I have done this video, so please watch that video before getting confused here. Okay, so now what you have to do, the first thing, like I said, we have to restrict the domain. Okay, so if it's the graph of the course, we're going to restrict the domain from 0 here to pi here. Okay, so you're going to restrict the domain from 0 here to pi here. Okay, so that's what it's going to do. Okay, so now we just have to reflect this graph by the line y is equals to x. Okay, so these are the steps. Just restrict the domain and reflect by the graph or by the line y is equals to x. Okay, so as easy as that. Okay, so now we are just going to take this part from here to here and reflect it. Okay, so let's draw a new graph. Okay. Okay, let me try to reflect it here so that when you draw here, you won't be confused. Okay, so let me try to reflect it here. Okay, so here you can see that we have our 1 here, and here we can see that we have our minus here, and minus 1 here. Okay, so I'm going to use another color to reflect this graph. Okay, so this is that we're going to get reflecting this graph. We're going to first to get this part of this line. It's going to be this side. Okay, so this means that it's going to be like this. Okay, so this is going to be this part of the graph. Okay, then this part of the graph is going to continue here like that. Okay, so now it's now easy. We just draw this graph clearly. Okay, so this means that the values of which are here are going to be here. So this means that this value is going to become 1, and this value is going to become minus 1, and the value of x are going to change to be y. Then this one becomes pi, and this one is going to become 0. Okay, so as easy as that. Okay, so now we just have to draw this graph in blue on this new graph. Okay, so let's draw this graph. It is going to start from here. It is going to start from here, then cut here, then go here. Okay, so this one is going to become pi, and this one is going to become like here is going to become minus 1, and here is going to become 1. Okay, then here at the middle you can see that it was crossing here at pi over 2. Okay, so it's going to become pi over 2. Okay, so we have reflected our graph by the graph y is equals to x, and we just flipped this. Okay, so this becomes the graph of y is equals to cos inverse of x. Okay, so as easy as that. We just have to restrict the domain and reflect the graph. Let's go to our last inverse graph of trigonometry, which is arctan. Okay, so The first thing, like other graph, you just have to draw the graph of tan. Okay, make sure you're able to draw the graph, that graph before drawing its inverse. Okay, so I'm just going to draw this graph from pi over 2, to minus pi over 2. Okay, so these are asymptote lines, minus pi over 2. Okay, so this is the only important part. That's why I'm drawing it. Okay, but if you ask to draw the graph of tan, you're just going to go to a range, to a given range. Okay, so this is going to be the only important part. So this becomes y, and this becomes x. Okay, so now let's see how do we draw this graph. The graph of tan, it goes like this. It is an asymptote line here. Okay, so it's going to be approaching like this. Then it comes here. It's going to be approaching like this. Okay, so now we are going to draw the graph of uh, of arctan. Okay, so we are going to reflect this graph by the line y is equals to x. Okay, so let me draw the line of y is equals to x. It does like this. Y is equals to x. Okay, so we're going to reflect this graph. Okay, so it's easy as that. Okay, so this part is going to be this part. Okay, so it's going to come here. Okay, so this means that it's going to be like this. Then this part is going to come this part. Then it comes back here. Okay, so this is the poor. But since we are going to draw again, we can modify it. Okay, so it's going to come like this. Okay, then after that, this part is going to come this part. Then it's going to be like this. Okay, this one should cross here. Okay, forgive me for my poor drawing. But this is going to be the shape. Okay, so let's now draw the new graph here with this shape. Okay, so like this. Okay, so this means that our graph is going to be like this. Okay, this was the reflection. Forgive me for this poor drawing, but this is going to be our drawing. Okay, so this becomes y and this becomes x. Okay, since this line is going to come here, we are going to change the values of x. This one is going to become pi over 2, and again here it's going to become minus pi over 2. Okay, and here it goes on and on, so we don't have to put the range here. Okay, so as easy as that, we have successfully drawn the graph of y is equals to arctan x. Okay, so this was that. This was by drawing the graph. We just have to first restrict. Okay, this is the restriction we did. We cut it from here. We did continue to draw another part, which will make sure that our graph is not 1 on 1. Okay, so you just have to draw this part here, then reflect it to become this one. Okay, so this one becomes our graph of arctan, and so the steps are easy. Restrict the domain, then reflect by the line y is equals to x. Our next part, I'm going to talk about sketching tips. Okay, so let me show you the sketching tips we have. Okay, so the first tip is start from the basic graph. Okay, so this is the first tip. Make sure you know how to draw the basic graph. Okay, so then apply the transformations one at a time. Apply this transformation, then apply this, and then apply this one at a time. Okay, usually start with x transformations, then go to y, and start with stretch transformations, then go to translation. Okay, so this is the tip I have. Okay, start from basic graph and apply the transformations one at a time. Okay, so then the next one, we have to plot the key points. Okay, e.g. the maximum, the mean, the minimum point, and the intercept. Okay, so this is a very tricky thing. You just have to draw the intercept where the graph intercepts the y, where it intercepts the x, and draw the maximum and the minimum of the graph. Okay, so it's easy as that. Then the next is for inverse graphs for inverses, just swap x and y of the original function, or reflect over the line y is equals to x. This is what we were doing on inverses. Okay, so this on the graphs. Okay, so the other thing is use asymptotes. Okay, make sure you are using asymptotes for the arctan. Just change the asymptote and redraw the graph as easy as that. Okay, so this was that. Okay, the other trick I have is if you want to draw the graph of inverses, you can just draw it on a paper and flip it, change x to become y. Then you can now see from the other side. Okay, so this was that on this graph. Okay, so make sure you're subscribed, and if you benefited, make sure you like so that you don't miss other videos which are going to be very fruitful and very informative.